All right, today we're going to talk about a really cool concept that kind of flips our whole idea of connectivity on its head: mesh networks. What if you could build a network that gets rid of the one thing we always thought was essential: a center?
You've definitely been there, right? You're at a huge concert or maybe a big storm rolls through and suddenly nothing. Your phone is a brick. So why does that happen? Well, it's because most of our traditional networks depend on these central points. And if they get overloaded or fail, the whole system just collapses.
And this really shows you the difference at a glance. Over on the left, you've got that classic network. Everything has to go through one central hub. If that hub goes down, it's game over. But now look at the right. That's a mesh network. Data can hop, skip, and jump along all these different paths. There's no one single point of failure that can take the whole thing down.
So this whole idea, a network with no single center, that is the absolute heart of what makes a mesh network tick. Let's break down what that really means. Here's the textbook definition, but let's make it simple. In a mesh network, every single device, we call them nodes, is like its own little router. It talks directly to its neighbors. So instead of a rigid top-down system, you get this really cool organic, interconnected web. Okay, so how do you actually go about building one of these webs? Turns out there are really two main flavors, two different ways to design them. Let's take a look. On one side, you've got what's called a full mesh. Now, this is the perfectionist's dream. Every single device is connected directly to every other device. You get the absolute maximum resilience, but let's be honest, it's wildly impractical. That's why in the real world, we almost always use a partial mesh. It finds that perfect practical balance, giving you tons of backup paths without the insane cost and complexity. And this little formula right here, this is why a full mesh is so impractical. The number of connections you need just explodes exponentially. I mean, think about it. For just 10 devices, you need 45 separate connections. For 100 devices, you'd need almost 5,000. It gets completely out of hand fast. Okay, so we've got this web of connections, but if there's no central traffic cop telling data where to go, how on earth does a message find its way from point A all the way to point Z? Well, this is where the real intelligence of the network comes into play. The secret sauce is something called routing protocols. The best way to think about them is as the network's brain, or maybe its own internal GPS. They're basically the set of rules that lets every single node make smart choices about where to pass a piece of information next. And what's really fascinating is that these protocols have different personalities. You've got your proactive routing. Think of it as the planner. It's constantly working to keep a full, up-to-date map of the entire network. Then you have reactive routing, which is more like the explorer. It doesn't bother finding a path until you actually need one. So you have a trade-off. One is faster when you hit send, but the other one uses way less energy just to maintain itself. Let's actually walk through how that explorer finds its way. So when one node wants to send a message, it basically just shouts out a route request to all its neighbors. Those neighbors pass it along to their neighbors, and it spreads through the network like a ripple in a pond until it finally hits the destination. That destination then sends a route reply all the way back along the path it came, basically leaving a digital breadcrumb trail for the real data to follow. It's so simple, but it's incredibly effective. So now we get to what I think is the first real superpower of mesh networks. They are almost unbelievably resilient. This is the feature that makes them so crucial in emergency situations. So how do they pull this off? Well, it really comes down to these three things. First, redundancy. There are always multiple ways for a message to get where it's going. Second, it's decentralized. There's no single weak spot you can attack to bring it all down. And third, that dynamic routing we just talked about lets the network adapt to changes on the fly. Let's watch this play out. Imagine a piece of data needs to get from node A to node Z. Right now, the network figures out the best path is through node C. Simple, right? Everything's running smoothly. But then, disaster strikes. Node C suddenly goes offline. Maybe its battery died, maybe it got damaged. In a traditional network, that connection would just be broken. End of story. But not in a mesh network. And the source material here puts it perfectly. Mesh networks have self-healing properties. That's an amazing way to think about it. They can actually sense there's a problem, block off the broken path, and figure out a way around it, all by themselves. And just like that, the network's routing protocols kick into gear. They instantly find a new path. Maybe this time it's through node D. The message gets delivered and the network just keeps on humming along as if nothing ever happened. Now that is resilience.
But being tough is only half the story. The second superpower of mesh networks is something called scalability. And what's really wild is that as these networks get bigger, they don't just get more complex, they can actually get stronger.
So what is scalability? It's pretty simple. It's just the ability to keep adding more and more devices to your network without everything grinding to a halt. Since there's no central server that's going to get overloaded, the network can just grow and grow organically.
And here's the secret to how it works. First, the growth is modular. Adding a new device isn't some complicated surgery on the network, you're just adding one more point to the web, which actually adds more paths and more capacity. And second, that intelligence is distributed. Every single node does a tiny bit of the work, so no one device ever gets overwhelmed.
Okay, so why does any of this matter in the real world? Well, look at the applications. In disaster recovery, you can set up communication networks in minutes when all the cell towers are down. For remote communities, you can bring the internet to people without having to lay thousands of miles of expensive cable. And for smart cities, this is how you connect millions of sensors for traffic, lighting, and utilities all seamlessly. So if we boil it all down, here's the fundamental trade-off. Yes, mesh networks are a little more complex under the hood than the simple networks we're used to. But what you get in exchange for that complexity is a system that is unbelievably resilient and can scale almost infinitely. And that really leaves us with one final big question. In a world where being connected is becoming more and more critical, especially in the toughest environments, you have to wonder, is this decentralized, self-healing web the future of how we all stay in touch?